والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. This is section 8.2 and it is about determining the required sample size for estimating a population mean. So we need to estimate the population mean. Okay, we are planning to estimate the population mean, and we have a question: how large a sample size do we need? How large a sample size do we need? And to answer this question, we need to know how much money is the budget to do the sampling, and how much will it cost to select each item in the sample. The answer of these two questions will help us to determine how large our sample is. But the minimum required sample size, or the minimum sample size required, would be found by this formula. If you remember, the margin of error in the previous section is z times sigma over square root of n. And if you interchange square root of n and e, then square root of n would be z times sigma over e. And if you raise both sides to the power 2, you will have n equals z sigma over e to the power 2, or z square sigma square over e square. So if you want to determine the minimum sample size اللي هو n required, you multiply z square times sigma square over e square. You need z square. How do you find z? You must have the confidence level. The confidence level should be given. So once you have the confidence level, you can find the critical value, which is z. You need the population standard deviation sigma, and you need the margin of error. The margin of error e should be known in the question. All right. So these three variables affect the sample size. If you increase z by increasing the confidence level, n would be increased. So higher confidence level requires a larger sample because z is in the numerator. Also sigma, if you increase sigma, n would be increased. So higher or greater variation, sigma, would require a larger sample, while e is in the denominator. So if you increase e, the sample size will be decreased. Or if you decrease e, if you lower the margin of error, the larger the sample would be, the sample size would be increased. So that's the formula. And for example, let us solve one question about it. Here, what sample size is needed? So the question, he will always ask about the sample size, and we are estimating a population mean. This sentence also has to be there. Sample size when we estimate the population mean, because we will study sample size when we estimate something else in the coming sections. So here, sample size when we estimate the population mean, which is mu, within plus or minus 50 of the true mean. The true mean is mu. So you need to be within plus or minus 50. So you need the error to be less than or equal to 50. So the maximum error we could accept is 50, okay, of the true mean. Using a confidence level, this is the level of confidence. It enables you to find z. Either you divide 0.95 by 2 and you find the z value from the z table, or you go to the t table and look for the confidence level 90% and go to the last row, which is the z row, and you take this number. This is the z value, which is 1.96. So z in this case is 1.96. So we have e and z, and we need to find n. What about sigma? if the true population variance, that's sigma square variance, remember, variance is sigma square. So sigma square is given in the question. It is 122,500. So what is the relation? What is the formula? N is Z square times sigma square over E square. Okay, so Z is 1.96. You raise it to the power 2. Sigma square, I have it already, 122,500 over E square, 50 to the power 2. You use the calculator to find the answer. 1.96 squared times 122,500 divided by 50 squared. The answer would be 188.24. Now, what is the required sample size? 189. You have to round up your answer, which is 188.24, and you choose 189. If you answer n equals 188, this is false. This is not correct. Why it is not correct? Because if you choose n 188, let us find e. What is e? E is z times sigma over square root of n. So e would be 1.96, which is z in this case, times sigma, which is a square root of 122,500 over square root of 188, the one you chose here. Okay, if you choose 188, what would happen to the margin of error? So multiply 1.966 times the square root of 122,500 divide by square root of 188 and give me the answer. The answer is 50.03. This is not accepted. This is not good because we need the error to be within plus or minus 50. يعني الإي لازم it must be less than or equal to 50. It cannot be greater than 50. If you choose 188, it will give you an error which is greater than 50. So you have to choose. The minimum sample size required is 189. And you cannot say 188.24 because this is a sample size. You need 188 families or 189 families. You cannot choose 188.24, for example. So the correct answer here is 189. This is the minimum sample size. After that, you can increase the sample size. If you have more money, you can choose 200, you can choose 190. That's up to you. But the minimum required sample size is 189 for the error to be within 50. Less than or equal to 50. Any question here would be solved similarly. Okay, all these questions would be solved similarly. Please, I put them for you to practice. Now, the second point would be if sigma is unknown. All right, and please pay attention here. Sigma is not given in the question. If sigma is not given in the question, you have two choices. Please pay attention. The first choice is to choose a pilot sample. What is a pilot sample? You take a sample from the population. Why you take this sample? To find S, to find the sample standard deviation. Because you need to estimate sigma. Sigma is not there. I can estimate sigma by S because sigma is approximately S. This is my best estimate for sigma. So I choose a pilot sample taken from the population of interest of size smaller than the anticipated sample size. What is the question here? We need to determine the sample size required to estimate mu. That's what we need to find out. But I don't have sigma. So what can I do? Choose a sample size. Choose a sample of size 30, 40, 50. Quickly, any sample of size 30 would be nice if 30 or more. And then find S and use S instead of sigma. And the formula, don't forget, the formula is N equals Z square times sigma square. Use S square here as an estimation uh, for sigma over E square. And you use Z, okay? So this would be the formula in case of pilot sample. You choose a sample quickly, find S, and use it instead of sigma. That's one way. The other way, if you know the maximum value and the minimum value in the population, then you can find the range of the population, because the range is the maximum minus the minimum. So using the range of the population, we can estimate sigma, the population standard deviation. How? Sigma is approximately the range of the population over 6. Why is that? Because we said that if you go 3 standard deviations to the right of the mean and 3 standard deviations to the left of the mean, you will almost have all the data there. So usually if you divide range over 6, you will get sigma. It's an approximation for sigma. So if you have the maximum and the minimum values, find sigma from this formula and use the formula again to find n. N is Z square sigma square over E square. Let us solve some exercises. Look to this example. The American Dairy Institute wishes to develop a 90% confidence interval. So this is the confidence level. And from here, you can find Z either from the Z table or from the last row in the T table. Confidence interval estimate for the mean. All right. For the mean number of gallons of milk consumed by per year by a family of 4 in the US. They wish their estimate to be within 3.5 gallons. So this is N. It shouldn't exceed 3.5. Now, what do we need to determine here? We need to determine, this is E, sorry. This is E, the margin of error. We need to determine N, determine the sample size required, okay? The population standard deviation is unknown. Sigma is unknown. So what to do? We choose a pilot sample of N equals 50. Is this the required N? Of course not. This is the size of the pilot sample. Why do you need a pilot sample? I need it to find the sample standard deviation. So I choose 50 families, okay, and I find the standard deviation. It is 62.5. So this is S. S is 62.5. Now I have S. I can use it in the formula to find N. So what is N? It is Z square times sigma square over E square. Well, I have Z 1.645 and I have an approximation of sigma, which is S. So I'm going to use S instead of sigma over E square, which is 3.5. Now find N. 1.645 squared times 62.5 squared over 3.5 squared. The answer is 8862.89. So what is the required sample size? 863. You always round up. This is the answer. This is the required sample size. Now, is he going to select? Are we going to select 863 families for our sample? No, we are not going to select 863. Why? Because we already selected 50 in the pilot sample. So we are going to select 863 minus 50 because we already selected 50, but this is the required sample size. Let us see the other question, 830. A sample size must be determined. Okay. For what? For estimating a population mean. All right. The confidence level is 90, so Z is 1.645. The desired margin of error, so E is 0.3. The largest value in the population. Okay, that's the maximum value in the population is 15. The smallest value or the minimum is 5. Once you have the maximum and the minimum, you can approximate the range. You can approximate sigma. Sigma is approximated by range over 6. So it is 15 minus 5 over 6 or 1.67. Now, this is the hint. Use the range over 6 option. Calculate the sample size required. I need n, okay, to estimate the population. All right, so what is the formula? N is Z square times sigma square over E square. So Z is 1.645 and sigma is 1.67 and E is 0.3 squared, and you find the answer and you round it up. This is what we need from this section. Let us just mention how to deal with this question. A decision maker is interested in estimating the mean of a population. Okay, so this is what we need to estimate based on a random sample. So what is the required sample? Random sample. She wants the coefficient, the confidence level 90%. So Z is 1.645, and the margin of error plus or minus 0.3. So this is the margin of error. She doesn't know what the population standard deviation. Sigma is not known. What to do? We choose a pilot sample. This is a pilot sample of 15. So the sample size of, or the pilot sample size, the size of the pilot sample is 15. Based on this pilot sample, how many more items must be sampled so that the decision maker can make the desired confidence interval estimate? What to do? We need what? We need sigma. How to find sigma? I cannot find sigma. So what to do? You can find S. You can use this pilot sample, put these numbers inside the calculator and find S. And once you have S, you can use it in the formula and find in the required sample size, which is Z square times sigma square. You replace it by S in this case over E square. And the required sample size, you round it up and you will have, for example, let us say 500. If the answer is 500, then how many more items must be sampled? 500 minus the 15 chosen in the pilot sample. This is the end of section 8.2, and inshallah next time we will take section 8.3.